and also showed the NUnique and unique function that contains the specific categories. And now I will just start with creating how to create a new column. Let's say we have the data. Okay, so let's print the data first. It is not data tips. So this tips. So this tips contains two numerical values, one numerical columns like total bill and tip. And let's say you want to create a new column that will represent the tip by total bill, that is the ratio that you would like to compute, and you would like to add as a new column here. Okay, so how we will do that? So let's first create a copy of the dataset because I don't want to modify the dataset. So the dataset name will be tips1 equal to. So to copy a dataset, just with the dataset name, use the copy. It will copy the dataset and create another copy of the dataset and save in this tips1. And next, you have to give the tips1, and to create a new column, say the column name is ratio, and then what would be in this column? That would be in the right side part, right side part actually. Okay, so within bracket, so from tips1, first I want to have to select, or you can use the dot block, or you can use directly the tip because it doesn't contain any space, it doesn't have any space. So I will use this method, that is tip. It will also select the tip, then divide with again tips1, and the column name is total bill. So it will create the ratio, and it will if you again print the tips1, so it will create a column ratio, but it has so much decimal points, up to 6 decimal point. So what you can do, you can also use make it 100%. So dot mul, that means you want to multiply something. I would multiply every values in that newly created ratio with 100, and dot round, that I would like to round it to 2 decimal place. And if you now run this, you will get that now it is converted to a percentage, and also it is rounded up to 2 decimal place. So in this way is useful when you want to modify the existing data set, because now the tips1 has been modified and it has been added as the ratio column has been added in the existing data set. Okay, so next, another way of doing this, this is the same thing. Another way of doing this is using the pandas assign function. Okay, so what this assign function does is same, but it will not replace the data or existing data until unless you will override the data. Like here also you give the tips equal to, and then you use the assign function. Okay, so similar in assign function, you have to give the dataset name dot assign, then the name of the column, say the name of the column is ratio1, and again the computation is same. You are multiplying with 100, rounding up to 2, and printing the head. So it also creates, earlier it has ratio, now it also includes ratio1, but it does not, I guess it does not change the tips1. So if you print the tips1, it does not contain the column actually, because it is not overriding. So dot assign don't override the existing column. So when we will use this, when we are doing some computation in a say step by step, like after taking tips, you are doing something with the data, then with dot you can take an assign function and create a new column, and over that column you want to do something. So on the fly it will create, but it will not permanently alter the existing data set. Okay, for example, say I'm taking the tips data set 1, then I'm dot with assign function, I'm creating a new column, say, and then with dot function you are calculating the mean, or say you are altering the values, or taking that column values and other column values and doing something. Okay, so on the fly it will create, but it will not alter the tips1. So for that cases, assign is used. And if you want to alter, then you have to go with this method, that you want to alter and create another column inside the data frame tips one. So next thing is filtering and subsetting data. Here we will also show the multi-conditional indexing or subsetting. So let's print the data first. The existing data is same, it's not altered. And this shows the top 5 observation. You can also use the tail, .tail, and it will print the last 5 observation, like 234, 240, 241, 242, and 243. Up to 244 we have data. So index starts from in Python 0. So it will be up to 243, 0 to 243, total 244 observation. Okay, and you can also pass say last 2 observation you want to select. It will show 242 and 243. Next, I will show most of the things using iLog. Still, I will also use in some places, most of the things with log, and in some places I will also show the iLog. Okay, so let's because our data has now index or default index. So tips dot head tips dot head. So it is our data set. Okay, and it has default index. So if I would like to select the first, second, and fourth index or rows, and the column only total bill, day, and time, then I have to use the tips dataset, then .log, and before comma you have to give the index values, because now it is not a string but a integer values in increasing order. Okay, so you have to give say 1, 2, 4 in a square bracket that I would like to select this index or these observations, and the columns total bill, day, and time. If you print that, it will only print those values. Okay, so 1, 2, 4 and total bill, day, and time. Say you would like to select the first 3 rows of the day and the time column. Okay, so first 3 rows, it is 0 index base. So tips.log, again before comma we have to give the row selection or index selection. So this colon means we are not giving anything before that. That means start from 0 and go up to 2. So 0, 1, 2 like this, and select the columns in a square bracket, day and time. So it will automatically print 0, 1, 2, day and time. Okay. In iLog, if you want to use iLog and do the same thing, so for tips.ilog, and as it is exclusive of the last index, so it will start from 0 and go to 3, but it should not. It won't include the 3, and it will exclude the 3. So it will go 0, 1, 2 up to 2. And for selecting say day and time, so for day and time, what index it includes? Say 0, 1, 2, 3, 4, and 5. So if you want to select it directly, so with slicing, say so 0, 1, 2, 3, 4, and 5. So if you are using slicing, say 4 to 5 with slicing, then you have to give up to 6. Okay, so that it will exclude the last one and only return the 4 and 5. So same case here, 4 to 6, last one is excluded. So it will already always select up from 4 up to 5 columns, and it will print the column like that. Now I will go for the data subsetting. Let's say you have some condition. Based on that condition, you would like to subset the data. Like I would like to select the all rows where the tips in the data set is greater than 3. So let's print the data first. Tips.head. So here is the tip column. I would like to print only or take only those such observations where the tips are greater than 3. Okay, so what will happen if I have to, what do I have to do if I have to select that? So let's say tips data dot tip, we can select a column because it doesn't contain any space, and if I use a conditional argument greater than 3 or not, and if I print that, it will give me a Boolean true and false series. So wherever the condition is in tips condition is greater than 3, it will print a true, or otherwise false. Okay, and if I pass this thing to a lock operator and in the row section, like if it is like this, and we are pasting this thing, this Boolean series in the row option, and or I'm asking to select all the columns. And if I comment this out and print this, it will select all the tip values where it is more than 3. Okay, and also print all the columns. And if you add a describe here, then it will give the statistics, and if you transpose it, it will show like this, like total bill, tip, and size. Why I'm using this describe? To show you that what is the minimum value right now. Minimum value is 3.02, because we have given a condition that it should be over 3. Similarly, lambda function we have already discussed, so I will just demonstrate. It is not important, but it is also used.
Discuss once again lambda function.
Okay. So lambda function is a function that is without name, but it also make the computation on the fly. So lambda function, like for example, list custom sorting we can do, or for example, say we have a value. Rather than showing example with it, I will show you the data frame. That would be much easier. Let's say that I have this tips data set, and I'm using a lock, and I would, instead of this conditional statement, I would like to use a lambda statement. So what this lambda statement actually does, it does the same thing, but on the fly. Sometimes it will helpful to do some computations, or say some for applying a particular function on that, and to alter the values. Like you would like to while selecting this observations, you like to do some computation, like you would like to add some value, or you want to check some conditions. That way the lambda function is very much useful. Rather than complicating it, I will just show how it works here. Let's say the tips data set is here, then dot log, and with lambda d, is notation here, it will take the data set, and with colon, what I'm asking lambda function to do, take d, the data set column tip, and check whether it is more than 3 or not. And with comma, and then take all the rows. It's same way we will print. And if you add the dot describe and dot t, it will also print the same thing. If you see the value 3.02, 3.02. And lambda functions, it little bit now might be you are feeling that it is complicated, but once you start learning the basics and revise that, it will be useful. But it is not essential here. You can do the subsetting also in this manner.
Day 3 IPNV.
In day 3 IPNV file, it is there. Durgesh sir has already taught that. And you can, if you have time in this weekend, you can check and go through it. Next, we have selected the lambda function already shown. So we have shown the lambda function for selecting a particular, or a this conditional subsetting, like whether the tips is greater than 3, then take all those rows that are satisfying this criteria. Sometimes we want the opposite, like we don't want where the tips are greater than 3. How we will select those data? So one option is to use like tips dot log, then with square bracket, you have to give this condition that the tips in tips data set, the tip is greater than 3, then comma with colon, that means before the colon all the rows, select all the rows where it is greater than 3, and select all the columns with colon after the comma. And here we will put a tilde sign. Okay, the tilde sign is a not operator. That means select those values which are, don't select those values, those are greater than, where the tips is greater than 3. It will select only those values where the tips is less than 3. Okay, less than or equal to. So if I add a describe dot describe, and after that, if I use a transpose of that, it will show that the minimum is now around so maximum value where it is tip. Minimum is 3 and maximum is minimum is 1, maximum is 3 for tip. Okay, so it does the opposite thing. So if I don't want to select those rows or want to ignore those rows and where this condition is satisfied, the tips is greater than 3 in the column, then ignore those columns, ignores those observations and give me only those observations where it is less than or equal to 3. Okay, so multi-conditional subsetting. Sometimes instead of a one condition of a particular column, you might have multiple conditions. Like you want that the tips should be more than 3 and the total bill should be greater than 10. Two condition could be, or tips is greater than 3 and the sex or gender is male. Only subset those data. That could be also done using a subsetting. So for multi-conditional subsetting, so if a condition, both the conditions, say we are applying for two conditions here, two conditions, let's say for a tip greater than 3 and total bill less than 10. And both condition, if for a row, both condition is true, then it will return true and return the row. If one of the condition, like greater than, say the condition is, I write the condition that tip is greater than 3, say, and total bill, that column name should be less than $10. If these two conditions satisfies together, both are true, then it will return a Boolean true, and it will subset the row where both the conditions are satisfied. If one of them false, the condition will fail, and both are false, then also it will fail. It will return false. Let's say, for example, you would like subset this 4 columns, sex, day, tip, and total bill columns, where tip is where the observation has tip greater than 3 and total bill greater than 30. So how we will do that? With single parenthesis inside, I'm giving the tips. This is called a piping, actually, step by step operation. Instead of writing like this, tips dot lock, if you write, it will go in horizontal direction. You can also use this kind of method where you give a parenthesis. That means whole block of code will be read as a 1, and let's say I'm giving the tips. Then next line dot, I would like to say apply the lock function, lock, and inside that I would like to give two conditions. This condition where tips is greater than 3 and tips dot has a total bill has greater than 30. These two conditions in the row side, and in the column side I would like to select these 4 columns. Based on those conditions, it will subset those rows where the tip is in the tips data set, tip is greater than 3 and the total bill is greater than 30. If both conditions are satisfied, both are true, then it will return true and it will return that row or that observation. Else it will ignore. If anyone fails, both are false, then it will ignore. Okay. So if I print that, now you can see that the tip is 5, like for tip is 5 and the total bill is 35, or tip is 7. All the conditions, both conditions are satisfied, all the cases. Okay. Next, say I would like to see that based on this condition, I have already I have taken out my data, but I would like to see, I want to rank the top 5 with the total bills. Okay, I would like to see the total bills in ascending order, false. That means descending order, decreasing order. Say after this subsetting, I have got this data, but I would like to sort the values. All the rows I would like to sort in decreasing order based on the total bill. So dot sort values option is there, and inside that you have to give based on which column you want to sort. So it will sort all the rows based on the total bill. Say I would like to see the top total bills from highest bills to the lowest bills. Okay, so total bill column, and it will put in ascending order, increasing order. So the comment we have to give it is false. So don't make it ascending. once we print that, now we can see that based on this condition, it has selected this 4 column and only it's a subsetted rows where the tip is greater than 3 and the total is greater than 30. And also it has sorted the rows based on the total bill. Now that you can ascending is false, that means it is descending or in order or decreasing order. So the top values, it is in decreasing order. The top value, if you see the total bill based on our conditional data, is 50.81. You can also add a head so that it won't print everything. So these are top 5 total bills based on this conditional subsetting. Okay, next, that is based on the AND condition. Here you don't write A and D AND. It won't take actually. Okay, so the notation should be this AND. And if I would like to go for a OR operation, when one of the thing is true, it will return the row. Okay, an OR operator is given by this vertical line. That is over the enter, you will get this. This is called an OR operator. It actually signifies that if one of the condition is satisfied, like if the row has a total bill greater than 3, or even if it is failed, let's say it is 2, but the total bill amount is greater than 30, one of the condition is satisfied, then it will return. That will be returned. Okay, so again, if I print or enter, then it will show. In some cases, you can see that the tip is 2.50, but the total bill amount 44.30. Still, it has returned because one condition is satisfied. What condition? The total bill is greater than 30. Even the tip amount is less than 3, not greater than 3. Okay. So pandas has also a SQL based query method. I will not go into detail, but just show you that also it has the SQL methods. SQL is a structured query language that is used for storing large amount data and also querying the data. It is used by industries and companies for storing the data. So
is used for which role? Which role? Data scientist and analyst.
It is also used by specifically for data scientists and data analysts, those who would like to query large amount of data, and it is stored in a structured way. That's why it is called SQL, structured query language. For querying, it is for data querying, it is used. And for query this, pandas also offers this method. So tips dot query, instead of this giving like this conditional statements, we can directly like human like syntax we can give, like in a quotation, tips greater than 3, if the condition is satisfied, tips greater than 3 and total bill greater than 30 in single quotation. And then after the ending of this query, you will select those columns in double square bracket because we want to return as a data frame. So sex, day, tip and total bill. And after then we have again applied the ascending order and it will again print the values. Next is, let's say we want to select 2 dates based on the observation or rows where the, okay, could you try tip greater than 3 and total bill greater than 60? One statement is true and other is false. Okay, let me try.
So AND operator, so it accept false.
Could you try tip greater than 3 and total bill 60? Okay, let me check. Let's check it here. Total bill is greater than 3 and 60 and tip is greater than 3. Okay, total bill is greater than 60. Does it contain 60 first of all? Let me check first. So tips dot describe, it will give us the statistics. So tips data dot t transpose. So what is the max value? Max value is 10.
One is condition is intentionally false, other is true.
So one is here you are giving it intentionally false. Actually, it is greater than 60, but the observation is not false, satisfying the criteria.
False and true, false.
So here, even if it is greater than 3, but this condition never gonna be satisfied, that's why it will be false. So no observation found. Okay. So because this, you have to, whenever you go for a data analytics or data analysis work, you have to see whether this observation is there, whether I have max value. No. If it is not there, this condition will never gonna satisfy. It always fault, because even if it is greater than 3 in some observations, but this always fails. But if I use a OR, then it will satisfy and print based on this condition, because this will always gonna fail. Okay, I hope this satisfy your query. Next is in. So is in actually used to subset the data, like we have used the conditional statements. For example, say in based on day, where the day is Saturday and Sunday in a categorical column, that is day column. I would like to subset all the rows where the day is Saturday and Sunday. So either the day should be Saturday or the Sunday. So either we have to use a OR operator and give two conditional statement, either the day is Saturday or day is Sunday. And rather than giving that way or creating it like that, we have a small another function that is very useful. What it does, it is called isin. So it will look for the values, whatever the things we will pass in the isin. Okay, so tips, from the tips we are selecting the, say, day column. You can use lock, ilock, whatever you want. Then dot is in. Inside that we are giving, we are trying to query that with isin, that whether this column contains the Saturday or Sunday. Wherever this condition satisfied, Saturday and Sunday are present, it will print true. Okay, and we can supply this thing, whatever this thing we have done to just generate this true and false Boolean series, we can pass this inside a lock operator to select those rows. Okay, so like tips day is in Saturday or Sunday, we are passing it inside the lock to select where this condition satisfies, and with comma we are selecting all the columns that by colon and not giving anything, so it will print. Now you will be wondering whether the day contains such as Saturday and Sunday. Okay, so what we'll do, instead of selecting all the column, here I will select the day, and also I will apply a value count or unique. It will show that it contains only 2, though it has 4 categories, but it contains Saturday and Sunday. So Sunday is present in first because of the order, how the strings are ordered. Don't bother about that. Okay. So with dot is in, also we can directly identify the conditional statements. Instead of giving the traditional one, we can use the is in function. Now come with the column selection. Let's imagine you have a large data set with 1000 columns, and it is an experiment. You have some start date or start time, end time like this, and you want to select all the columns where the name starts with starts date, or the names ends with end, some text like column name then end date or something like that. Okay, so just for demonstration purpose, this tips dataset doesn't contain actually large amount of large number of columns. Still, I will show how this works. Say head. So these are our columns. Let's say we would like to select where the columns start with S. So this size also start with S, smoker start with S, and sex start with S. So how we will select? Tips.lock, select this colon means before comma means select all the rows, and for column I will apply a str based or string based method here. So tips dot columns, all columns, this also support a str based method, that is string based method dot str and dot starts with. So if I take this out and go and paste it in another segment, and if I give S, so it will give me a Boolean series or array. Here it is array. So first one is false, total bill does not start, it doesn't start with S, it is also false. Then it start with S, true, true. Again it for false, false, and true. So if I pass this thing to the column position of a lock, it will select all the columns that starts with it. No, start with S. Okay, sex, smoker, and size. And we can also use a head so that it won't print large amount of data. So this. Same way, it also supports the ends with. If some string or column name starts with, say, here any common 2 star ends with E. Okay, time and size. So I can pass E, and it will automatically select time and size because it starts the string with or column name with E. So it would be useful when you would like to select, say, start date. Lots of column has a column name starting with start date, this variable start date, that variable or that variable end date, or that variable end time, like this. So this kind of selection you can done when you have large number of columns. So coming to the missing data, now how the missing data could be identified or quantified. Okay. So for that, what I will do, I will read another data in the data folder. Also, it contains a tips_NA, and this data set I have already opened, and purposefully I removed some of the observation. Like for day, this observation is missing. Time, this observation is missing. This observation for total bill missing. For total bill, this one is missing. Okay, this way it is presented. So I'm reading the data again, pd.read_csv, data sets, tips_NA, this time would be the name, and .csv. From datasets folder, tips_NA.csv I'm reading. And while reading, I'm also changing the data type for sex, smoker, day, and time with as type. So with a dictionary, the key would be the column name and value would be the type in which you want to convert. So sex category, smoker into categories, day into category, time into category, and I'm printing the observation. So some observations where I have purposefully omitted those observations, here you can find that it is represented with nan, not a number. That is missing. Okay, like here it is nan, here it is nan, here it is nan. So if I use the info method to get a basic description of the or information of the data set, so what it will show that how many are non-null values. Now total observation is 244, but for total bill now only actual value contains 242. 2 are missing. This contains all. This also 2 missing. Here 1 missing. Here 1 missing. Here 2 missing. It contains all. Okay. So what if I would like to see how the where the null is actually. Okay. So for let's say for column for data set tips_NA, I would like to select the column total bill or like that, total bill. You can also use the lock operation or iLock, whatever you want. And I would like to apply a function. There is a function in pandas called isNull. It will query that whether the observation is null or not and give a true or false. So is null. And if I apply this function on this series or column, okay, so it will return wherever the observation is present and it is not omitted, it would represent as a false. Wherever it is true, it will show true. We can also apply this thing to other columns. Okay, like say there is another function with isNull. There is also similar function that works similarly, isNA. You can also apply the isNA, it will return same. Okay, there is no difference. So isNull versus isNA, and we would like to say subset the data. Say we would like to subset the data where the total bill column values are missing. I would like to take out all the rows where the total bill column has any missing values. Only the total bill column has. Okay, not entire data or entire row. So what we have to do, say I have already shown this part in above. So tips_NA, that is our data set with missing values. Then we are selecting the column total bill and applying the isNull or isNA, whatever you want. Let's say isNA. and it will give us this Boolean series. And if I pass this in the lock operator or lock selection indexer, or for subsetting we use lock, and in the row position before the comma. Okay, if I paste this, let's say copy this, instead of null we would like to use NA, we paste that, and with comma we would like to select all the columns. So it will, wherever the condition is true, wherever the null values are present, it will take an out. Screen not visible. Everybody has that problem. Screen is not visible. Should I share the screen again? Please type in the chat box. Visible. Rizwan, I think your internet is slow. Otherwise, you should rejoin.
Old link.
Or you might have joined through the old link. So we are pasting the link here. Join through that. Or copy that one. Okay. So this applying this function is NA on a series or a column total bill, giving us wherever it is true or the missing data is present, it will represent with a Boolean true, and wherever the missing data is not there, real data is present, it will false. If I paste this whole statement in position of the row in a lock operation, like for selecting, lock usually used for selecting the subset of data, and we are pasting this in the row position before the comma, and what will do, wherever it is true, it will take out those rows. Okay, wherever the total bill is missing. Okay, so total bill missing nan for this row number 3, that index 3 and index such a 13, and all the other observation might be there or might be none. So these two rows for the total columns are having none actually. Same way, we can also use for, instead of going for a particular column, I can also use the is NA for and apply to the entire data set. So data set name is tips NA. I'm applying the is.NA, and let's say I'm not giving right now head, but I'm printing the everything. So what we will do, where every observation or every cell, wherever there is a NA value or nan value or it is missing, it will print a true. Okay, so here it is true, here it is true, it's missing. So what if you want to sum it, that each column how many observations are there that are missing, but true value we can't sum it. We can sum it, but I will show one trick here. So what we'll do, we will take the data, apply the is.NA, that will give us this, and convert it to the integer as dot type. If you apply on that as dot type int integer, and let's say I'm not giving head, I want to present everything, so hash after that, and if I convert this true false to an integer, so true will be represented as 1 and false will be represented with 0. So now you can see that wherever the missing value were present, there was true, but right now it is converted to 1, and wherever it was false, right now it has converted to 0. And as we have 0 and 1, now we can apply a sum function over that. Okay, so we can directly apply sum function taking each column, but Python or pandas has also a functionality that will make it very easy, like tips.NA, then is NA, then we will apply sum along the axis 0. So along the axis 0 means row wise means this way for each column, and it will sum. How many ones are there? That many, each column contains NA values or missing values. So for total bill 2, tips 0, sex 2, smoker 1, day 1, time 2, size 0. And if I would like to see number of missing values row wise in this direction, column wise for each column, for each observation, so I have to sum in this direction. It will show that how many observation, how many values in the observations are missing. So the axis would be 1, or you can also type columns here. It also supports that. So for each row, how many observations are null or missing, it will print like that. The next thing I will show that once we have the data in this format, we can add all this column wise. For say sex, I will add 0, 0, 1, 0, whatever the number of observations like 0 and 1, and we can compute the mean, divide by the number of observations. What we'll do, it will give the mean number of missing values. Mean, it will automatically calculate the mean in this way. Okay, so what we can do tips underscore na data, then we applied the is na, then applied the dot mean function. Okay, so I will go step by step. Tips, so na, then I will apply over the all data set is na, then instead of sum I will apply a mean. So mean function will print the mean or percentage of missing, that is mean number of missing, mean value of missing here, the na values actually. So 0.008, so around, if I multiply it with 100, so mul with 100, so it will convert it to percentage. So 0.81% missing data, missing data are missing in total bill, like 0.81 here 0, and you can also round it to say 1 decimal point. So 0.8, 0.8, 0.4, 0.4, and 0.8. That way you will get the total number of total percentage of missing values in a particular column. Next things, sometimes we have a continuous data, but for counting or for say for modeling purpose, we sometimes make it as a discrete. Like for age, sometimes age is in continuous data, but we will sometimes we make it as a categorized data, like the category could be say less than 18, 18 to 45, 45 to 60, greater than 60. So pandas also offers two functions to perform and to discretize a continuous data using cut, and another is qcut or quantile based cut. So let's first see the tips data set and dot head. How to remove the row that contains nan. Okay, that is a part. How to remove a row which contains nan, that is a part of data cleaning process, and it will take at least 2 days, but I will just show you the dot drop method that will drop the rows where any value in a row is missing. So for tips data set, let's go tips na dot describe or info, go for info. Right now data status is like that. Now I will show just one method, like tips na dot drop drop na method. Yes, drop na. If I apply this method drop na, what will do? It will drop all the rows where any of the value in the row or in a row wise, like this way. If it contains a missing value, it will drop that row. It contains no missing value, it will hold the row. There are other functionality that will take time to explain. I can't do in this session, but where based on certain condition, like if a column contains 30% of the missing values, drop that column. Or also we have different imputation method, like we want to impute or add the value based on the mean of the column with the original whatever the data available in the column, or median, mode, a constant value, or say you would like to call it a na value for a categorical data case. So that could be done, but it will not covered in the session because it is another topic, that how to clean data, that is another topic. So
will provide extra reading material.
Yeah, we can provide additional reading material, and this missing data handling methods are available. I have already provided the links. You can go to the data school, that is a channel in YouTube that has everything what you want to know, like from preparing data to cleaning data using pandas. That links I will also share end of the session. So if I apply this drop na, and now I will apply a info method on that, on the after whatever the data we get. now it will show that after dropping, we have 238, 238, 238, 238, 238 non-null value. That means original value, not missing. So it has dropped all the rows. Even the column does not column value, say for this column does not contain, but as this row has a 1 here or a true case, if you see in this case true, that means in a present, it will drop entire row, but it will reduce the data size and also the information, because some columns has valuable information. So that's why the imputation come, like impute with mean or fill with mean value of that column. But it is another topic. So we'll give you the link if you an additional material. If you would like to go through it, you can go through it. Okay. So now the discretizing or binning a continuous data. Let's say we have the tip column. It is a continuous data, numeric and continuous, because it has decimal place. It could take any value like 1.11, 1.12, 2.11, like this. And say I would like to make 3 categories. I would like to count, or I would like to discretize into 3 categories. Say 0 to 3, 3 to 7, and greater than 7, or 7 to 10, because our maximum value is 10. Okay. So how we will do that? We need to use a pandas cut method. So pandas also offered a cut method. So pd.cut, we want to cut which one? The tips, from tips dataset, the tip column, and whatever the bin size will be 0 to 3. That means 2.9999 like that, and 3 to 6.9999 like that, and 7 to 10, 9.9999 like that. It will come like that, or I will show that what would be the binning range. And whatever the range it will create, I would like to name it and give a label. I don't want it to show that it is the bin size 0 to 3 or 3 to 7. I would like to name the 0 to 3 range as low, 3 to 7 as medium, and 7 to 10 as high. And if I print, and I'm overriding the data with a new column, creating a new column in the tips dataset. Okay. So now we can see where the value is 1.01, it is showing low, with a new column has been inserted, and based on this conditions like 0 to 3, if it is 3.50, then it is medium, and somewhere it is 7 to 10, it will be say high. Okay, and it is a now categorical column. We can use we can select this column and count the values, how many observations are there. So tips inside that we are selecting the tips underscore cut and applying a value count that will give the frequency count, how many low, how many medium, and how many high observations are there. So you can see that low is 146 observations are within range of 0 to 3, and 95 are say 3 to 7, and high are around 7 to $10 tips. Okay, so most of the person who has visited the restaurant provided a low tip of $1 to $3. Okay, say let's look for the data type. Now it is a categorical data types with ordered equal to true, because it has order. Low, then medium, then high. It has a particular order of the categories. That's why it is a ordered. It is an example of order has a categorical data. Okay. So next is Q-cut or quantile way such a this binning actually. So what is a quantile? Quantile, if I say 50th percentile, that means it is observation of median. Like if we have a series or column, and if we sort the column from small to higher values, and if we would like to know the 50th percentile or quantile, then we'll have to observe we will get a median value or middle value of that series, where below that 50% of data are present and above 50% of the data are present, that value. Similarly, we can also get for 30% percentile, where 30% of the observations are below that and 70% of observations are above that. Let's create a series and let me demonstrate that. So here is a series that contains from 1 to 11, and it is an even number or odd number. So the middle value here will be 6, I guess, because below that 5 observation and above that 5 observation. Okay, so 6 is the 50th percentile. if I create the series and save in X, and X dot quantile, it has function. So if I apply the quantile and check 50 percentile, 50 or median, it will give me the median. So median means 6. If I would like to know what is the 13th percentile, 30th percentile, 30, and below which 30% observations are there and above which 70% observations are there, it is 4.0. Below which 3 values are there and above which 70% of the values are 7 values are there. Okay, so this way it will based on certain quantile values we can divide it. Like for tips, if I take the tips column and compute the 33.33 percentile, and for say tips data 66.66 percentile, if I compute that, it will show that 33% of the data are below this value, tip value, and 66.77% are above that value. Similarly, 66.66% values are here below this, and 33.33 above that value. It is 66 percentile, 66.66 or 33.33. Why I'm showing this? Because when we will cut this using quantile with equal bin size of quantile, then it will bin like that. I will show that. Let's cut our tips data, tips column into 3 quantile values.
How do you?
So pd.qcut, it will divide the or create a bin based on the quantile values. Okay. So here tips data set, I want to divide it into 3 quantile values. Okay. So 0 to 33, 33 to 66, and 66 to 7. Okay, like this, 66.66 to 100, like this. I'm ignoring the fraction, and I'm saving this in tips.qcut. Now you can see that it started from 0.99 to 2.03. 2.03, that was 33%, and then 3. It is 2.032. I guess 3.24 will be there. So this column has been created. Let's first check the value counts and what are the values available. So tips.qcut, we selected this column, then value counts, and I'm not showing this right now. So 0 to 0.999 to 2.03, the first 0 to 33% quantile. So 33% quantile up to 33% quantile, 83 observation. Then 2.03 to 3.25, 80 observation, and 3.25 to 10, 81 observation. And it is not in order. That's why I applied the short index. I would like to index short the index, so it will show in this order: 0 to 0.999 to 2.03, 2.03 to 3.25, 3.25 to 10.0. So it has divided based on the quantile. So it is approximately same, because 33, 66, and 66 to 100. So next, this is just by default they have named it like that, but we may also like to label this. So it is a low quantile value or medium quantile or high quantile or high, low value, medium value, or high value. With pd.qcut, you can also supply these labels, and it will add as qcut. We are adding a column named tip underscore qcut, or overriding the existing one. So it has low, high, medium, like that. Okay. Next is a very important topic that will always be useful in your research. That is called a group by aggregation. So for that, I would take 2-minute break, just drink water, or say 5-minute break. Just drink water, have tea. We'll start, because this you need a fresh mind, and this should be the most important topic for today, I guess, because we will need everywhere in the research.
We will start at 4:10.
Okay, we will start at 4:10.
8-minute break.
Okay, 8-minute break. So we were resuming the session here, and here I would like to talk about group by aggregation, which is one of the most important thing in pandas and even in research. For example, let's read the data again, fresh data with tips. And let's say I would like to know the how many female smoker are there. Let's first select the female column. So to select that, tips.log, we already know how it works. Screen share. Okay. Sorry. Yeah. Okay, now it's shared. Now it is available. Now you're able to see my screen. Please type in the chat box whether the screen is now visible. Yes. Okay. So for group by aggregation, let's read the data, the fresh data with then again the tips data. Okay. And let's say I want to select only the female columns and I want to know the how many females are smoker. That's for assumption here. Just take assumption from the data set. We will get some values. To select the female column or sex column with female values, again we have to use the log, and before the comma we have to give the row. Okay, row conditional statement. Here the conditional statement is tips.sex equal to female. So in tips data, the sex column wherever it is female, and after the comma we are giving a colon. That means select all the columns. So what it will do, it will print all the rows where the sex is female. Next thing, let's say instead of all the columns, I would like to select the smoker column. So I have supplied now instead of colon a smoker, the column name. And now I would like to know, now it is selected the female observations or female rows and the smoker column. And for female observations for the smoker column, I would like to count the values. How many females are smoker or not? Okay. So from this observation, it says that no is 54 and yes 33. Similarly, I can do it for male, like for sex equal to male and smoker, and again value count. And now it is showing me 97 and 60. This is little bit a tedious task, because if I go for instead of female, if I go for the day, then I have to type 4 days for 4 type of segregation for smoker. Like for Friday, if it is Friday, how many are smoker, how many are non-smoker, if it is Sunday. So when the number of categories increase, it will also increase your you have to type several times and also make the several statements to compute the same thing. And there is a trick which is known as pandas group by, where you could group the data. Here we have grouped the data in male and female, and we can do it in one liner. Okay, so how it happens in pandas. So tips data set. Then next we use the group by. So group by, and inside group by we are giving sex. What that actually means? It means virtually you can imagine that what actually pandas is doing, that it's taking tips data set and it subsetting the data set, making a separate data set, say for the assumption, where one data set contains only male sex, another data set contains female sex. Okay, so you have now 2 data set virtually, one for male and one for females. And now from each data set, one for male and one for female, we are taking out the smoker column. We have grouped the data set based on male and female, 2 data separate data set, and from each data set we are taking the smoker column. Okay, and now if I add a value count, again I will repeat the tips data set. Then pandas is separating into a 2 data set based on the sex categories, like for male and female, and from each data set we are taking out the smoker column and then applying on that smoker column for each data set a value count. So what it will does, it will give us this. Here is the sex female and male, and here is the smoker status no, yes, 54, 33, 97 and 60 counts. Okay, So it now giving us the whole thing that we have done in 2 steps, like segregating female, then male, and taking out smoker and counting the value. We have done it only just this much code. Like it grouped by the data based on sex. Then from each data, we are taken out the smoker column, and for each smoker column, we are counting the values. And it has given like this. So sex, female and male. For each sex, female has no and yes, and male also has no and yes, whether the smoker status is no or yes, and what is the count. Next, what we'll do, this has provided us in a index manner. It is Python index manner, but instead of male and female as an index, we have an option called unstack. If we provide that unstack, what it will do, this index will be made as a column, and it will transform it as a data frame. Okay, so now let me again do in separate cell so that you can see the difference. And here the dot unstack. So first one is without unstack. So here female and male, and now what it has actually done, it has converted this as a smoker status into a column. Okay, so the sex is female and male, and whatever the smoker status was there, it is a multi-index actually. One index here and another index, one index for smoker and another index for sex. So what it does, it converted the sex female and male into a index, and the smoker and its such categories as a column. So it will give as a sometimes in Excel it is called pivot table, I guess. So it created table where now you can see the counts. For female, how many are non-smoker? For female, how many are smoker? Male, how many are non-smoker, and how many are such a smoker? So next, we can also, after unstack, inside the value count, there is also option for normalize. So it will give us the proportion. Okay, so normalize equal to true. Instead of count, let's say we want as a proportion. And if you print that, it will show like this. But I want to multiply 100, so it will give us 100%. And after multiplying, I would also like to round it up to a 2 decimal place. So dot round 2. Now it is showing that 62.07 of the females are non-smoker and in the data set, and 33.93 are just smoker. Similarly for male. Okay. So next, we can also use a rename function here and give a column name as percentage instead of what we are seeing here. But instead of unstack, I will show another method here. Okay, so in unstack, it is okay that it is giving us a tabular format, but sometimes we don't need in a tabular format like this, but we need it as a separate column in a data frame. This percentage, say you want a percentage column. Okay, so how we will do that? So tips, then dot group by, and inside group by we are categorized based on sex. Then we are selecting the smoker column and dot multiplying with 100, and then we are also renaming it rename. So whatever the column we will generate, we will want to rename it as %. And next, what will happen up to if I print up to this? Somewhere something has gone wrong. Value counts, we haven't applied the value counts because we have to give some aggregation function. So this smoker we would like to count, value counts bracket normalize true, and now if I enter, it will show like this. So these are the index. We know that using dot reset index we can remove the index, or this index could be made as a part of the data frame. Okay, so what we'll do, we will apply a dot reset index, and this will show as a column whatever the index earlier it has, like if I comment it out here. So earlier it has multi-index, there is a smoker index, and sex there is the index. and with reset index, what we'll do, it will remove those index and reset it as a integer value and make those index as a column in a data frame. Okay, and next we will apply the round function also, dot round. Now we are getting it as a data frame. So similar to data frame operation, indexing, slicing, everything can be done with that. And even if you can use this for plotting, later in next week we will show how to plot. So this is for based on just one category like sex. We have categorized the data set, made a 2 data set based on male and female. What if we want a data, we want to aggregate or say group by based on say day and sex both. So for each day, say for Friday, there again the day will be categorized based on sex. Say for each Friday, male and female, for each Saturday, male and female, and for each Sunday, male and female, for each Tuesday, male and female. You want to compute the mean for the tip. For Friday, how much mean tip has been was given by male, those who arrived with the group in the restaurant. Similar for female for the Friday, for Saturday, for Sunday, and again for Tuesday. So same thing, just in group by. First we will group based on day, so it will based on the group day. So it will segregate the data based on the day, like Sunday data, Tuesday data, Friday data, and Saturday data. And after that data segregation into 4 days, again the day-wise data will segregate it based on sex. So Friday data again for male and female, and Saturday data for male and female, Sunday data male, female, Tuesday for male and female. And from each subset of data, like the data which contains Friday and for male, we are taking out the tip column and we will compute the mean. So from that, all these segregated data sets based on the day and sex, we are taking out from each data set the tip column and we are applying a aggregate function. So earlier we are using the value count because we are dealing with the smoker column, that was a categorical column, that's where counting the values. We can't apply any aggregation function like mean, median, mode, we can't apply, but here we will apply. Here we are using the dot aggregate. So first we are selecting a tip, then we are group by or segregating the data first based on day, and within each day based on sex, and from that we are taking out the tip column and we are aggregating using the applying the aggregate function, and inside that we are giving mean. And again we are resetting the index so that it will return as a data frame, and dot round will round up. Okay, so now we can see that for Friday, female has given an average tip of 2.78. For Friday, male has average tip of male who has visited the place has given around 2.69 average tip. Similar for Saturday, Sunday, and Tuesday. Okay. So this same thing can be also achieved by another function called pivot table instead of a group by. That will I'll show, but it is not important if you don't understand right now, but still I will show. So tips dot pivot table, that includes 4 arguments: index, columns, values, and aggregate function. Let's see the data set so that I will tips dot data tips dot head. So in index, what we want in index, because we want to represent it like that, this one, well, this one. In index, I want the sex column, and in column, I want the index, I want the day column, and say in column, I want the sex column, values. Okay. So what we have to provide in index, we are providing the day. So day would be index, column would be presented by sex, and values will be taken from the tip data set, tip column, and aggregation function will be mean, and we are rounding it to 2 plus. Let's print, then we will show, it will show that index is day, so index is now day. Columns are sex, so sex, female and male. Our values for each cell for this combination of 2, like for Friday and female, Friday for male, should be taken from tip, but as a aggregate function with by aggregating as a mean. You can apply standard deviation, STD, and it will show the standard deviation. You can also use median, show the median value. Whatever you like, you can apply here. It supports around count, sum, mean, median, standard deviation, variance, minimum, maximum, product. first and last. Okay, so this is very useful when you would like to aggregate based on two categories or two columns. Next, I will show the n largest and n smallest function that is very much useful when you want to identify which are the top five, which are the top smallest, top five largest or top five smallest. So first, what I will do, I will comment it out. I'll not show this first. Say for tips day column, I'm counting the value for each day. Okay. So here, as day is a categorical column, so it will count how many times Saturday is present, how many times the Sunday was present, how many samples or observation. So 87, 76, 62, 19. For some categories, say you have 20 categories and you want to stack, you want to know what are the top two categories. So here top or smallest categories, top smallest such two categories. Say here I would like to know the smallest such categories, the two smallest categories in ascending order, increasing order. So you have to add n smallest and the top two you want the smallest one. So if you enter, that will show that 19 Friday and Tuesday 62 are the smallest one. So if you not provide again and you print 19 and 62, 19 at top because it's the smallest one, then it's a 62. If I use top 3, it will show the top 3, 19, 62, 76. Same way the largest, let's say we want the top 3 largest, 87, 76, 62 in decreasing order. That would be very much useful when you have some count or some proportion and you want to stack, you want to know which one has largest of what are the top 5, what are the top 6, like this. So here is an example that I think it is very much important when you would like to create a new column. Say I would like to create a column based on two conditions. Say here the conditions are: create a new column called low high. The column name would be low high inside the tips data set. If total bill paid is less than 20 and tip paid less than 3, then add a low in the column, else add high in the column. So based on two separate columns, which are total bill and tip, and there are certain value conditions, I would like to add low or high. So NP, that NumPy library has a where function where we can apply the two conditions. So first condition is this and second condition is this. And if first condition satisfies, then put a low in this column, or the second condition satisfied, then put high in that action. Okay. So if I here the condition is if the tips total bill is less than 20, then put low. Means the tips total bill less than 20 and the tips both the condition will satisfy, then put low. And if both the condition is not satisfied, sorry, I was wrong. If both the conditions satisfied, because we are using an and here. If both the conditions satisfied, then put a low, else put high. Okay. So if the total bill in any row is less than 20 and the total tip or the tip amount is less than 3, put low, otherwise high. Let's print. Now you can see that the total bill is less than 20 here, 16, but tip also low. Here total bill is greater than 20 and tip is also greater than 3, so it is high. And a contradictory like 26, 3, 15, 14. Like here the tip is greater than 3. Okay. Not satisfied, and but the total bill is less than 20, so it is false. That's why it is high. So one condition failed here, like the tip amount is greater than 3 here. So both conditions are not true. One is false, so it is false, and so it is returned high. Okay. So this way, based on one column or another column characteristics, you can put some values. Even you can put here the tips, add from tips dataset, add the value of say sex. Do that. That if the condition satisfy, both the conditions satisfy, take the value from sex if it is for the for example, for say it is 21 and 3.5, take male if the both the conditions satisfied from this data set, else another column. We can also do that. It would be very useful when you want to, based on two conditions of two columns, you want to create a new column. Next thing, I will show some functions that we directly can apply over the series or data frame. These are map. Map is specific. Map, apply map, and pipe. Map is specifically used for coding the data. Like sometimes we want to code the male as 0 and female as 1, like that. Okay. So again, I will reading the data, and next you can also read from here. So I would make a copy recorded data set. I will make a copy of the tips and save into tips recorded, and I'll show the head. And next, what I will do, I will try to code using the map function. So how this works? So tips recorded data set. From that, I'm taking the sex column and using the map function. And inside the function with curly braces, I'm giving a mapping object that map female as it is a curly brace. That means as a dictionary we are giving, and this is the key. Key is the thing that we would like to alter. The female string, we want to change it to 0 and male as 1. And we want to override, or we can override on the sex column, and I'm creating a new column in the tips.recorded data set. Okay, so sex underscore recorded, it would be that column. And here you can see that when the female was female, it was 0, and male it is 1. So female, it is now 0, male it is 1. So sometimes this coding is required when you will do machine learning, or you will fit a linear regression model. Then the libraries, some libraries has some requirement that it won't take such a categorical like string data. You have to give it as a numeric value or discrete value. Next is apply. It can be applied on a series or data frame. Okay. So for that, I would load another data set. Is called a Titanic data set. Here the Titanic underscore train.csv. It is a data set from that describes the survival status of individual passengers. So when the survival, whether certain those who are riding the ship, whether they have survived or not survived, their statistics is available in a data set, and it is a very popular data set in Kaggle. It is a competitive site, and where it contains the following columns. P class means passenger class. 1 is for first, second, third. Survival status, whether the person survived, 0, not survived, and if you survive, it is yes, 1. The name is name of the person, sex is sex of the person, age, and SP mean number of siblings or spouses aboard, okay, on that ship, and perch number of parents or children aboard, ticket is ticket number, fare is passenger fare, cabin is cabin number, embark port of embark, that is Canterbury or Queenstown, what is the port. So we will read the data same way from dataset folder Titanic underscore train.csv. After reading the data, it will look like this. I will minimize this. So it is look like this actually. Different data and name. Let's say I would like to split here the name contains the first name. This is the last name and first name. Okay. So I would want to split those names at the comma position. And I would like to take this as a last name and put it in another column because I need that name and I want to do some computation or something. Okay, so how we will do that? So let's take the Titanic dataset, then the name, and with str function functionality we can use the split, and where we will split with wherever the comma is present, like here I will split, here I will split, here I will split. Okay. So it will return us a list for each observation name, like this the last name with comma first name. Again for last name, comma, here is split it, first name. Okay, up to certain dot is there. That means more is there in right side, like this. And from that I would like to select. We know how to index the list with the 0. It is 0 index, it is 1. It is 0, it is 0, it is 1. It is 0, it is 1. So here what I will do, I will apply a function, a lambda function, small function. What it will do, it will take the list, and from that index out is a 0. So up to that we know. Then I use the apply function and using lambda x with colon. That x means here this whole list, and from that we are selecting the 0th index. So it will return this first name, this first name, last name, this first one. Okay, and we are saving into a new name. And if I print the head, now you can see that we have created a new name column that contains those last name. Okay, that is a small application. Another application here, I will load another data set. It's called drinks, and different country wise beverage consumption is there, like beer serving, spirits, wine, total liter of pure alcohol, and continent. Okay, so we will consider only these 3 columns for our for this to show you the how the apply works, and we can use any function. You can take a existing function, or you can create a function and apply on that data set. So let's take the drink data, and using lock operator, we are taking this 3 column. So this column means take all the observations or rows, and the column we are using slicer or slicing from beer serving up to wine serving. So beer serving, spirit serving, and wine serving. This 3 column will be taken, and over that we want to apply a max that it is index. So index wise, this column direction in this index wise, what is the max value in this column? What is the max value in this column? What is the max value? It is in this column. It is the max value. So if I apply this, it will show that beer serving contains 376 as the max value, spirit serving 438, wine serving 370. Across the index, that means this direction, vertical. And we can also, instead of index, we can also supply the column that will give row wise or column here the column direction, column wise, whatever the maximum value for among these 3 values in each observation. Okay, like here it is 32, here it is 0, here it is 25. So same way here, now I've given the column, and now it shows that first one is 0, one is 30, 132, 25, 312, 312 is there. Yes, 312. Okay. So apply map is another function that usually we apply element wise on a data frame. So in this data frame, whatever the where the data frame, here the data frame. Let's say for this 3 column, these are in integer. I would like to make each of one as a float. Okay, so decimal point .0 should be located here, and for that I have to take each column and apply a function. Rather than we can also do it using apply map that will element wise each element in the data frame, but we will select only the numeric columns. Not we can't do it over a country column because it contains string. So this 3 column. Okay, and again with lock I'm taking the from beer serving to wine serving, and again this part I can right now cut and paste somewhere else. I will just show. I don't want to override it. So okay. So drinks data dot lock. Again, all observation from beer serving to wine serving. These 3 columns. These 3 numerical columns because we want to convert to a float, integer to float. And then with apply map, we are applying the float function. Okay. What it will do? It will convert every values to a float value instead of integer. So you can also write a custom function and apply that you would like to add 0.05 here for every observation. You can do that. Create a function and apply here. So next is pipe. The last thing here. After that we'll take a half an hour or 15 to 20 minute break. So the pipe operator is used when we are doing something in chaining way. Chaining way means that time I showed you that with say tips, then from tip I using lock I have taken something, then I applied say dot group by. So it is a chaining one after one. So from tips something coming, then from that we are applying something and getting something, then over that we are applying something or getting something. So on the fly, let's say from tips with locks we have selected something and we want to apply some function here to convert it. Say the tips was in dollar, you want to convert into a rupees. So with pipe here we apply, we create external function, we define external function here and creates a conversion. We will create a function here and we'll define whatever the function will do. It will convert say dollar to rupees, and we will supply this function here. Okay, it will convert here on the fly. Then let's apply a group by over that. Group by, we can apply here a group by. Again, we can apply say a aggregate function. Again, we can with dot we can apply aggregate function here. Then dot aggregate. Then again aggregate. Okay. Then we again apply another function. Say we have created pipe with pipe. So on the fly we can create we can apply a function that we might have defined elsewhere. We can on the fly we can apply a function here, say function 2 or say function 1, and it will on the fly do the computation and again return to whatever the object to the next line or next function. For this purpose it is actually used. So here let's calculate the average, say average tip. Find average instead of weight, it should be tip. Okay, so here I have defined a function called find average tip. So it will take the data frame and also the column name, and it will return df.column.mean. Okay, so tips data set, and we are applying this function, and we are applying also we are in pipe we are giving the function name that we would like to apply over the tips, and we are giving the column name for which we would like to calculate the average mean. And if we press enter, it will show that it is 2.99. And it is just an example, but main application is like that. The pipe, with pipe we can apply a particular function to convert a particular column value something in on the fly while doing some computation. So this is the pandas. So I have covered it, I guess, extensively that we want for research work or for doing computation. And I also have provided you some resources, like here we have covered the importing libraries, how to import data, checking data types, column selection based on data types, then changing data type, unique that we applied for a data frame, and n unique that we applied on a series to know the unique values, creating a new column based on certain conditions, then filtering and subsetting, is in to select or with a or condition or is in condition, then different ways of column selection, missing data identification and computing the percentage or sum, then converting a continuous data to a discrete or bin data like range, then pandas such a group by to grouping the data based on a particular category, and then computing or aggregating some value like mean, median, mode, something that, then n largest and smallest, and applying some different types of functions on the data set. And I would like to show that if you would like to learn more about pandas, okay, then go to this channel. I will show, I will also share the link. This is the best, I guess, best pandas description is available with this playlist, and this is from his data school and his cabin, and all the things are available what you want to do, and it is the best available resource if you prefer video. If you don't prefer video, then I will recommend going with this this book, Pandas Monex Cookbook by Matt Harrison. This is a wonderful book. You will even get how to handle missing values. It is also there, and it is in very detail with defined data set and examples. Now we will I will end my session, and we will take a break of
5:05. We will start.
We will start at 5:05, and next we will discuss when we have multiple data sources, how to compile those data or add those data vertical wise, column wise, and that is a joining data from multiple sources. How to join, because sometimes we in research get multiple data from multiple source, and that belongs to same thing, and would like to join to those data set to perform some computation or analysis. That will be taken by Durgesh sir. Okay, we will start at 15:05. You can now
16,
16, 17:05. Okay, sorry, that is
15
5,
minutes break.
5.
Laptop.
Okay, okay, 15-minute break.
So type here when we introduce.
Mm. 17:05.
Welcome back, everyone. I hope you had your refreshment. So, am I audible? So I have shared my screen. So please go to this link and download the day 4 again. I have added two IPYNV files. So download the whole day 4 folder. Also, I have added the images and like session 13 and 14. But you better you download whole folder again. Day 4 again. So I think everyone is back. It is 7:05. So can you all SAB member please enable the chat. For all members, please enable the chats. So everybody came back. Should we start the session? Please type in the message. Please everybody type in the chat if you are present in the session. Please type. So those who are already present in the session, please go to the link shared and download the day 4 complete day 4. So I'm downloading the day 4. So it is zipping for me. So it is has zipped and it will give me the download option. So I will save here on the desktop itself. So I will save on the desktop and I will name it as like day 4 only, or say this save.
You can ask replacing what's happening. Ask replacement.
Let us delete this. Not back. Rename. I'm renaming the old folder as .back. It is opened in VS Code. So I will close VS Code. Cancel. Rename back. Oh, couple of files are opened here.
Try again. Try again.
Yeah. So I've renamed the old folder as _back, and I will do a phrase download of day 4. Download. So I will extract here, and so I got this folder here. Then I will open a VS Code, and inside this I have desktop and this. So okay.
फोल्डर उसको रीनेम कर दीजिए, दो तो सेम ही नाम है।
Right.
बात कीजिए और उसको अंदर वाला कॉपी करके बाहर पेस्ट कर दीजिए।
Now I have placed all the folders in desktop in the folder inside day 4 17/4/2022, and I got 2 new Python files, session 13, session 14, and one new image folder. So let me start VS Code, and we can go file, open folder, and like we can choose this file, select folder, and so this folder is opened here. So we can select session 13, merging data sets. So we have to select kernel. We will select the data science kernel. Yeah. So we are set. I hope you guys have also downloaded the files. So as we are running short of time, we will proceed, and please type in the chat box if you are facing any issue. Otherwise, we will handle all the doubts at the end of the session. Okay, so in this we will cover how to merge two data frame, two Excel sheets. So what are the different ways of merging? Many times we are generating like the multiple Excel sheets through our experiments. So how to merge those Excel sheets, how to process on those types of Excel sheets. And part of it is also similar to the way we process the query in SQL database. So we'll briefly in this session, we'll go to the concatenation of the two data frame, row wise merging, column wise merging, merging on the intersection of a particular column, like the and other 4 types of join: inner join, outer join, left join, right join, etc. So first we have to load the library, import numpy as np, import pandas as pd. At least you should take these 2 lines if nothing from this workshop. Import numpy as np, import pandas as pd. Even if you can say this line, then you can boast that you have learned the numpy and pandas package. So we'll run this, and yeah. So full form of NumPy is numerical Python, and pandas is like the alias dash pd. So here we got three tables. Table 1 we have a pin code and location. Table 2 also we have a pin code and location. Table 3 we have the known for and the state. So see, the format of the table 1 and table 2 are same. Both have the pin to same column, pin code and location. So here we have the pin code of Guwahati, specifically IIT Guwahati 781039, pin code of Delhi, pin code of Kolkata, and in the table 2 we have the pin code of Moradabad, pin code of Bangalore. So if we want to merge these two, table 1, table 2, how should we merge? Should we merge table 1 and table 2 like the column wise or the row wise? What I mean by the row wise, should we keep the content of table 2 uh, below the content of table 1, or should we keep the content of table 2 in the right side of the content of table 1? So how should we merge table 1, table 2? So can you, anybody type in the chat, how should we merge, like logically what will make more sense, the row wise merging or the column wise merging? So column wise merging will make us 4 column, row wise merging will make like only 2 columns, but it will increase the number of rows. We are discussing about table 1 and table 2. So yeah, row wise merging will make more sense. So let us see how using the pandas we can merge the two tables. So first we'll define the table. So we have not defined the table. So uh, uh, throughout the course we have like the shown you defining the table using the dictionary structure, but there are other ways also we have shared in the blog links in the previous session how to define a data frame using the multiple ways like the list of list and other ways. So here each column, like the each column is a list and the name of the column is the key. So and the value is the column's value. So we have a two column pin code and location, and the values of those two column are put as list. So we define df equal to pd dot data frame. So d capital f capital, and then pin code is one the key, and the value is 781039 and so on. Location is other key, and the Guwahati, Delhi, Kolkata are value. So let's run this and we get our data frame df1 with column pin code and location, and default we have not set any index, so default index will be 012. So just to uh, revise your how to save the data frame to csv file, I have written here df dot to underscore csv. So you can save uh, any CSV file or any data frame to CSV file using this syntax, and we are saving inside the location data sets, and we are naming it pin code underscore ct underscore 1 dot csv. So when we run it, it will be saved successfully. And if I show you in the file structure, like you can see that inside data 1, pin code underscore pin code underscore ct underscore csv dot csv is there, and we have 3 columns. One column is for index 012, though it was not part of our main csv file, but it was also written in the csv file. Okay, we'll further we will further see how to like the how to make data frames to not to write this column. So we'll see in the code below. So first we'll define the second table like this, pin code and the location. So we'll define pin code like this, again similar to the first syntax, pin code 244001 560066 and location equal to Moradabad and Bangalore, and we run this code and we get our second table. So similar way we can save our second table, but here intentionally I have set index equal to false, so that we don't want to save this index 0 and 1. So when I run this code, it will save another of CSV file pin code underscore ct underscore 2 dot csv, and it is saving inside the dataset folder. You see here inside, because we have given the location like that. So if we open, we get only 2 columns. like in CT pin code underscore CT underscore CSB, we are getting 3 columns, but here we were getting 2 columns because we are using index equal to false. Now we want to concat. We want to join these two. So concat means combine these two CSV files to data frames. So it is simple. Put all the data frames in the list and apply pd.concat. So pd.concat df1 and df2 and axis equal to 0. So it will combine the row wise. So we are not saving in the result anywhere, but we can like the save the result also. So we will just do like this, and the two data frames get combined by the rows. So if we want to save like this, so we can save it df like the df row concat equal to pd dot data frame, and then we can print uh, df row concat and it will print here. So you see that few index are repeated. The index of the table 201. So there is a duplicacy in the index because it is copied as it is. So even if it has a duplicate column, it will copy. So it was the demonstration to combine the two data frame using the row wise axis equal to 0. So however, if we see table 2 and table 3, combining row wise will not make sense because the pin code and known for are the different columns. So here combining column wise will make more sense, like this pin code, this location, and known for and the state. Okay, so suppose we combine the data like the we define first data frame 3, like in the similar way we define data frame 1 and data frame 2. Known for is one column and state is other column, and we get df3, and we are just saving df3.csv so that you can see by opening it. And so you can just use axis equal to 1 pd.concat df2 df3 axis equal to 1 to combine it column wise. Okay, so any doubt till now? So you got 4 columns. Unlike the previous case, you got only 2 columns, but the number of rows gets increased. Here we get 4 columns, but the number of rows becomes same. How to update the index? Reset index, as you have seen in the previous session, df. So you can just use the like this df.concat. So just I will add one row here, df dot reset index drop equal to true. This will reset the index, and it has then created a new index 0 1 2 3 4 like that. Okay, so now we'll see how to join two data frames. Like the in SQL we have the join when we join two table, because we don't want the redundant data to store, so we often divide the data into multiple table. So here, why do you wrote index equal to false before saving to CSV? Okay, I think you have joined recently. We have shown you that index while saving to the df1.c2csv, here we have not used index equal to false. So if and like the you see the df1, it is the 781039 Guwahati, 110020 Delhi, 700001 Kolkata, and it has the index 012. When we save is to .csv, df1.2csv without giving the index parameter, by default it is true. So we will get it like this. It will also save the index. So we get 3 column. Original data has only 2 column. So we get one extra column which is index 012. So if we don't want to save this extra column, what we can do? We can just write index equal to false. Like here in the remaining example, we are doing index equal to false. df2.csv datasets pin code underscore ct underscore 2 index equal to false. So if we just open pin code underscore CT underscore 2, we are getting only 2 columns. We are not getting the index. So I hope this clarifies your doubt. So now we will see the two tables like the movies and the rating table. So here we have the movie ID and the title of the movie. Like first ID is 1 and the title is Toy Story. For second ID is 2 and the title is Golden Eye, and the bracket there is the release year, ID 5 Copycat, and ID 4 Get Sorty, and I have not seen any of these movies. So in the second table, like it is the rating table. It may be like it is the data like uh, where the movie is stored and the movie rating data. So any user, this is user ID and this is movie ID, and he has given the rating, and this is the time stamp at which he has given the rating. So same movie ID can be like the rated by multiple users. So I have just given a small snapshot. It has more call rows in both movies and rating. I have just given a small snapshot, and now we want what we along with this we want to combine these two. How we want to like the combine these two so that we have the in the resultant table we have the movie ID, we have the title, we have the user ID, we have the rating, and we have the timestamp. So our like we have to join this table so that resultant table have this 5 column, because one column is repeated here, that is movie ID. So 2 columns here and the 4 column. If we sum up, we get the 6 column. But since the movie ID is the same column, so we don't want to duplicate that. So in the resultant, we are getting only 5 column, and the corresponding to movie ID, movie title needs to be added. So you can see here like the corresponding to movie ID 1, same movie title is added, and there are different user ID who are giving the different rating at different timestamp. So this is our task to combine the movie table and the rating table into moving ratings merge table. So I hope you understand when we can combine both the file, how to second files has index. Okay. So then we can just load the data, movies data. It is present in the datasets folder. So we can run this script and it loads the movie data, and it has printed the here only top 5 rows because we have not given any entry here. Suppose we give 10 here, then it will print top 10 rows. Okay, so by default, let's go with the default. So it will print top 5 rows. So we have the movie ID 1, Toy Story, movie ID 2, Golden Eye, movie ID 3, 4 rooms, movie ID 4, Gate Sorty, movie ID 5, Copycat, like that. So if we want to know how many rows and how many columns are there, we can just use movies.shape, and it tells us there are 1682 rows and 2 columns. So there are total 1682 movies present in the movies.csv. If we want to know how many there are like the unique movies, so just we are selecting movies id. So like this movies id means we are selecting one column. Movie id is one column. Movies is a one data frame dot movies id one column dot n unique is a function. It will count the number of unique value. So when we run that, we get 1682. So all movies are unique here by the id. There are not duplicate id. None of the id are duplicated in this movies csv. After that, we uh, load the ratings tables. So rating tables, we have the 4 column user ID, movie ID, ratings, timestamp, but we don't have the movie title here. So we see that like the here same use like the same movie ID can be rated by multiple user. Similarly, same user can give rating to multiple movie ID. So if we see the ratings.shape, we have how many rows? 1000, 10,000, 100,000. So 100,000 rows and 4 columns. So if we see the number of movies ID, how many movie ID are there? So we can again, ratings is the name of data frame. movie ID is the name of column, ratings.movie ID, and n unique is the number is the function which tells the number of unique entry in a particular column or a particular series. So ratings.movie ID dot n unique. So we have 1682 movies, and the same was the case in the movies table. So now the current task is to find the number of unique entry of the users. So this is the task that you have to do now. Write the code and type in the chat. You have to find the number of unique users. So this is the table. You have to find the number of unique user ID, number of unique users. So I will wait for few seconds, say 20 seconds for your input in the message. You have to tell me the commands to find the number of unique users or the number of unique users. How many unique users are there in the ratings table? So being interactive will benefit you all.
You can use a dot based method, or you can use the ilog based matrix, whatever you like for selecting the column.
Yeah, ratings is the data frame dot user underscore id dot, then n unique is the method, n unique is the method name, and then if just we type like this, because it is a method name, function name, we have to open a bracket and close a bracket. We get 943 unique users are there in this rating table. Okay. So ratings.log, you are writing ratings.log. So you are selecting using the log and you are giving the double colon. Okay. And you are giving the movie ID column movie ID. But we need to select the user ID, right? Not the movie ID. Movie anyway. I will first type you what you have written, then and unique. Yeah, instead of comma there is a dot. So rating
double colon, single colon.
No, just get me. Rating is not defined. Ratings is there. First, I need to see the message. So it is giving me 1682. So this is a correct syntax. Then I will tell you what is the meaning of this syntax and what it is giving. It is giving me the unique number of movie in the column and why this syntax is working. So, and what is the meaning of this? So you are not giving any start value. You are not giving any end value. You are not giving any step size. So by default, it will start from 0. By default, it will like the end with -1 means last entry, and by default step size will be 1. So I think this makes the sense. This is giving you the number of unique movie ID. So like the inside this, so you have the two things. Here you have the row thing, and here you have the column thing. So you have here, could you please repeat the difference between unique and n-unique? Okay, so unique, it will print just the number of unique entry, and n-unique, it will print the number. So it is printing the unique ID 242302 like that. Whereas n-unique will give us the count.
N is stands for number of unique value. That is the count.
So like this, n unique will give you the count, whereas unique will give you the unique entries in those column. Okay. And so the task was to find the number of unique users. So it instead of movie ID, we have to just write here user underscore ID, and it will give us like, okay, unique, it is exceeding. So we have to use n unique 943, same as here. and instead of 2 colon we can skip, and even we can use the single colon. And in the second syntax even we can use like this, like even we can, even if we don't give like this, even this will also work. This should work.
लॉक के साथ work नहीं करेगा.
Oh, lock, we need to give a comma at least. So yeah, colon and comma also we need to give. Okay, 943. But if we don't want to use lock, we can just give like ratings dot user underscore id dot and unique. Okay. So in particular, unique gives full entries. No, unique gives full unique entries, excluding the duplicate entries. And n unique gives the count of unique entries. Unique gives the unique entries in a column, and unique gives the number of unique entries. So it is a count, and unique gives a count, whereas unique gives the unique entry. Okay, so this is done. So ratings dot, so just to see that there are duplicate ratings for a single movie, so just we have selected ratings dot loc, ratings dot movie id. This is the condition for the selection. In the row side we have selected those row for which movie id was 1, and we have selected all the column, and we have printed few entries only, so top 5 entry. So if we want to see like the 40 entry, we can see there are 40 entry for one. There are more than entry for the one. So if we want to see 100 entry, so 110, we will see the 110 entry, 110 rows into 4 columns. So I think this line is clear. Ratings data frame dot loc filter, and this is the criteria of filtering. So on row side you are selecting those entry for which movies id is equal to 1, and column side you are selecting all the column. And on head, if you don't give any entry, by default it will print the 5 values. So this was just to show that for a single movie there are multiple ratings by the multiple users. So now comes the merging the movies and ratings. So if we see the movie dot columns, we have the 2 columns, movie named as movie id and title, and data type is object. When we see the ratings column, we have user id, movie id, ratings, timestamp, and data type is object. So when we merge pd dot merge movie dot rating, and when we print, so we get like movies rating. So movies rating dot head 10. So just we will comment this line, and then, or otherwise just if we can write the print statement here, then it will also work. So just we'll write a print statement, then it is printing the combined column, the movie id and the title is added, user id, ratings, timestamp. So we got our desired thing. So we wanted to merge this two movies and rating table into the movie rating merged. So we wanted 5 column like this, and based on the single, like the, we have not told explicitly based on what we need to merge this table, movies and rating. So it has automatically identified because it has the same name, movie id in the movies and movie id in the rating. So it has merged movies and rating table based on the common name, movie id in the movies and movie id in the rating. So now we will see how to merge if there are different column names in the both side. So for that we will just like the rename the column, as you have already seen how to rename movies dot rename columns movie id. We are renaming it mob id and in place equal to true. So it will not return anything, and it will in place change the movies data frame without returning anything. So it will not take any temporary space to do so, and neither it will return anything. So if we don't give anything like that, if we just cut this, so it will return us a new data frame with a movie id renamed as uh, movies ida dot head. Okay, so we just need to comment it, and then we need to run it. Then we see that movie id is renamed, If we don't give the in place equal to true, it is returning, but it will not change movies. Okay, so then we are uncommenting this and we are putting it back in place equal to true. So it will not return anything. And okay, double comma here. It will not change, return anything, but it will change in the movies data frame itself, movie ID to MOB ID. Now we have the two table, movies and the rating, but here in the movies we have MOB ID, in the rating we have MOBIE underscore ID. Now we want to combine these, so we can use pd.merge movies rating left side column, left side, because first we are giving the movies, so movies become left on MOB underscore ID, right on MOB underscore MOBIE underscore ID dot head. And when we run this, we get again the similar thing, MOB, but we are getting both the column, MOB ID here, MOBIE ID here. So previously we were getting only 5 column, but here we are getting 6 columns. Okay, so now we will see that how to join with left index. Like if we want, like the movies dot set index, here the index is 0 1 2 3, so we want to reset the index of the movies. So we have reset the index as the MOB ID. So when we see the ratings dot head, we have the user ID, movie ID, rating, timestamp. So now we are merging uh, both the movies and rating table, where left index we are keeping true, we are keeping the left index in the merged column, but we are like uh, we are on the right side we are taking movie ID as an index, and we are combining, then we are getting that we are getting the left index like the 24 to 454 957, but right side we are not getting any index, we are getting the movie IDs. So here also we are, instead of like the getting the 6 column, we are getting 5 column here only. So next we will see how to join with two different index. Okay, so ratings, now we are resetting the index of the rating as movie IDs. So ratings equal to ratings dot set index movie underscore ID. And when we see the ratings table, the ratings index has been changed to the movie ID. So now we are merging the movies and the ratings. So left index true, right index true, and the head. So we are seeing only the 4 column here: title, user ID, rating, and timestamp. So unlike the previous case where we were seeing the 5 columns.
So what is the difference here? That for in first case we are combining with two columns. Okay, like both are movie ID, MOVIE. In second case, we change the first the movie data frames column name to MOVID, and the second data set, that is our ratings, that has MOVIE ID. So when that based on which it will combine is different, then we have to specify the based on what it will join, whether it's for left column, what is the left column and what is the right column. In third case, we showed if instead of a if a data set contains a movie ID, the movie ID as an index, the left data set, that is our movie data set. But the right data set, that is our rating, it contains the column that movie ID, but it is not as an index. So one data frame contains it as an index and another data frame contains it as a column name. And how to join that? And fourth case is there when both the data set movie IDs are index. Then how to join that? Okay, there are 4 conditions.
So I hope this is clear. If you have any doubts, you can go back and see the IPython and see the video, and then type in the query section in the like the chat section or in the dedicated channel for the query. So now we'll see the 4 types of join. So there are 4 types of join supported by pandas, and these join are also defined in the SQL structured query language, MySQL query language. So the pandas support all 4 types of join: inner join, outer join, left join, right join. And through the pictorial representation, I will show you what I mean by different 4 types of join. So we have considered 2 tables for the demonstration of join, like pin code underscore location and pin code underscore state. So you see the pin code here is the common column name in both the table, and we want to join this table. So how many entries should be in the merged or the joined table? It should be 4, it should be 3, it should be 2. How many entries should be there if we join these 2 tables? That is the case, like the which what will make more meaningful, whether we want to join the table vertically or horizontally. So yeah, somebody has written 3. Yeah, 3 will be more meaningful, like pin code location, and that location is present in which state. Yeah, correct, 3. So we will see that there are different ways, because there are some entries like the 78 of Guwahati is present. Guwahati pin code is present in both the tables, 781031. Bangalore pin code like 11020 is present in both the table, whereas Kolkata pin code is present in only the left hand side table, and Uttar Pradesh pin code 221001 is present in only right side table. Okay, so now we have to combine this, and so we first define these 2 tables. So we named it a data frame 4, where we define using the similar syntax pd.dataframe. So pd.dataframe is the key lines to define a data frame, and inside it we have shown you through the dictionary case. There are other ways like the list of list and explicitly giving the names. We have already shared the blog link. It is very simple, you can see that, but here for the sake of uniformity we will follow the dictionary structure. So here the key is the column name pin code and the value is the column list. Similarly, key is the location and the value is the value are the here Guwahati, Bangalore, Kolkata, etc. So when we define this data 4, we get a pin code location column similar to above in the picture. Similarly, we save this. So this is not so much necessary here. And we define data frame 5, and we get data frame 5 table similar to second table pin code underscore state, first table pin code underscore location. And now we want to combine these 2 tables. Okay. So we will combine using different joins. So first is the inner join. So we will include only observations that are found both in data frame 4 and data frame 5. So this is the resultant inner join. So 781039 is present in both the table, left table and right table. 110020 is present in both the tables. So we will get 2 entries that are common to both data frame 4 and data frame 5, and we'll put into the merged inner join table, and we will have the pin code, location and state. So I think output is clear how to make inner join, include the observation that is found in both the table, that is inner join. So based on a particular column, and that is the common column, that is pin code. So by default it's taking the common column name. So df merged inner equal to pd.merge df comma d4 how inner. So this is the syntax, and so it will print. You can see that it is exactly same as the picture, merged inner join 781039 Guwahati, Assam, 110020 Bangalore, Karnataka. So this is how we find the inner join of the 2 table. So we can save if you want. Syntax is same, df underscore merged underscore inner. This is the data frame name, dot to underscore cv, then the file name where to save, and index equal to false if you don't want to save the index. Then we have the outer join. So the entries will be common to both. Like it is the OR condition. So we have the 3 entry in the first table, 3 entry in the second table, but 2 entries are common. So the total there are 4 entries because 2 entries are common, and there are 2 entries, one entry that is not present, like that is exclusively present in the left table, and one entry that is exclusively present in the right table. So for the state, Kolkata will not get any state. We don't have any state information in the pin code under state for the Kolkata entry, so it will get NaN. Similarly, for the Uttar Pradesh case, we don't have any location information, so it will get NaN. So this is the will be the output of the outer join. So entries will be the OR of both the table. It was the in first case is what intersection of the both the table entries based on a pin code column. Here it will be the OR condition, either present in table 1, either present in table 2 based on the pin code column. So df underscore merged underscore outer pd dot merge, same pd dot merge was the same command. Here we have given the 2 data frame, and in the next parameter how equal to outer. In the first case, we have given how equal to inner to make an inner join. Now we will give how equal to outer to make outer join, and we get the desired output. So thus we have learned how to make an inner join, how to make an outer join. Next, we will learn how to make a left join and how to make a right join. So left join include all the observation present in data frame 4 in the left hand side in the merge table. So we have 3 entry. So we'll put 3 entry. So for the third entry, Kolkata, we don't have any information in the state. So that information will get NaN. So you see here in the above case also, the Kolkata information was NaN here. So NaN, not a number. Missing, it is a denotation for missing values. So df underscore merged underscore left. So this is a naming part. You can name it my table, anything. This is a variable naming part. So just for the sake of clarity, I have named it so df underscore merged underscore left, pd dot merge df4 df5 how equal to left. So it is as simple as that. So if you want to merge 2 table, pd dot merge, give the 2 data frame how inner, outer, left, right. So this you get the left join. So you can save the left join table, and then comes the right join. Include all the observation in data 5.4, that is right side in the merge table. So we have the 3. We don't have the Kolkata entry in the right side, so we'll include the Kolkata entries in the merged right join. And for corresponding to Uttar Pradesh, we don't have any entry in the pin code location, so we'll have a NaN here. So df underscore merged underscore right, pd dot merge data frame 4 data frame 5 how equal to right, and done. So you can save this table. So we will wait for 2 minutes for any query, and then we will proceed to the last session. It is a very small session, how to handle exceptions and the error in the Python, and what are the different types of errors. So we'll wait for 2 minutes for any doubts. You can type in the chat, or if you need a little longer time for a pause, like 5 minutes, you can tell so in the chat. Next session will hardly take 15 minutes. It will not go beyond 15 minutes. Can you please repeat the left? Yeah, sure. I hope inner join are clear. I hope inner join is clear and the outer join is clear. Nagendra, can you please tell whether you are clear with the inner and outer join? Yes, okay. So we'll proceed with the left join. So we have the 2 table, data frame 4. Data frame 4 is pin code underscore location, that is on left side, and data frame 5 that is on right side, pin code underscore state. We want to join this table. So how we want to join? We want to join on based on the common column name pin code, but we want to include only those entry that are present only on the left side. If that is not present in the left side, we will not include in the merged left join table. So you see on the left side, we have the Guwahati, we have the Bangalore, we have the Kolkata, but we should see the pin code thing. 781039 we have present here, 110020, 700001. So we'll include these three entry: 781039, 110020, 700001. So for 781039 we have location Guwahati, and corresponding state we will get from the right hand side as Assam. For 110020, we have location Bangalore from the left hand side, and from the right hand side we will get state as Karnataka. For the last entry in the left hand side, 700001 Kolkata, we will get state as Uttar Pradesh. No, sorry, my bad. We don't have any state information in right side, so we will put a nan, not a number or undefined value or missing value in the state. So this is the left join. So I think left join is clear now. So include all the observation as given here, include all the observation that are found in data frame 4, that is left hand side in the merge table. So syntax is df underscore merged underscore table pd.merge df4 df5 how equal to left. Good. So anybody have any more doubt? Otherwise we can proceed to the last session. Can you please explain the role of x is equal to 0, x is equal to 1? So I think this was also taught in yesterday's session. So x is equal to 0 is the combining the row wise. So I will tell you, but also see the IPNV file of yesterday lectures. So here, so x is equal to 0. We are combining the two table using the row. So we are just putting contents of table 2 beneath the content of the table 1. So we want like the table 1 pin code location and table 2 also pin code location. So the combined table of table 1 and table 2 should contain only 2 column pin code underscore location, but it should contain 5 entry, 3 row entry from here and 2 row entry from here. So that is the x is equal to 0. When we combine two table in the x-axis side or in the row wise. So similar thing, the x is equal to 0 is very important for various numpy operation and other operation. So you can see the detailed example in yesterday lectures notes also. So but yeah, x is equal to 0 means row wise operation and x is equal to 1 means column wise operation. So x is equal to 1 here. If we want to combine this table 1 and table 3, we have to combine x is equal to 1 because these two column information are different. So resultant table of table 1 and table 3 will give 4 columns. Shall we finish today's lecture and take a final break? Yeah, without break. Yeah, next final session is just a 15-minute session. So yeah, I too agree that we should finish the final session soon. So this is final session, error and exception. So handling errors and exceptions are common to programmers and software developer. And believe me, like if you understand your errors, half of the job is done. And if you are not understanding your error and exceptions, or you don't have experience to handle your errors and exceptions of any programming language, then you will face nightmares in understanding, in developing the things. So this was the best thing that I learned during after the first failure in learning the programming language. First thing I learned is understanding the error message of the compiler, the C compiler. I was learning the C on 128 MB RAM computer without any internet support, without any teacher support. I had just the support of latest C, my mind, and the compiler. And it happened to be the best teacher because the way I learned to understand the gap between my way of thinking and the compiler things. Okay, so in Python's error can be broadly categorized into three type of error. We have the syntax error. So what do we mean by syntax error? You can map this to a grammatical error. So for every language you have so something that is not mapping to a grammar, so that becomes the syntax error. So for every programming language, there are a syntax, how to define a variable, how to define a class, how to define a function, like that. So if that your code is not following the syntax, it will be categorized as syntax error. Code is not valid according to the syntax. The compiler or the interpreter, so the two things, compiler and interpreter, I will not go detail into these things, but you make a note of these things. What do you mean by the compiler? What do you mean by the interpreter? So Python is an interpreted language. Okay, so maybe in the class or some last part we'll go through that. So the syntax error, your compiler or interpreter is not is telling that some part of the code is not correct syntactically, means when you map it to the natural language, grammatically it is not correct. It is easy to fix. Okay, then there are runtime error. So syntactically valid code, but usually due to invalid user input or exhaustion of resources, like the RAM size exceeded required for a program, like this runtime error happened. Or in the C, you are trying to access some memory location that doesn't exist, the memory corruption issue, having the null pointer, etc., etc. Those are the runtime error. And the last is semantic error. Error in the logics. Code executes successfully, but output is not as expected. So this is the most hard thing to debug, but with practice, you can ace these errors also. Okay, so notes examples are taken from a book, A Whirlwind Tour of Python by Jake Vanderplas. And just I want to give you one comment about learning any programming language. It is same as learning a new language. And observe how a baby learns a new language. He speaks the language, he listens to a language, and the way of things in the process of that, he learns the language. So he obviously makes mistakes, but there are people around him to correct him or her, or some support to correct, and he's not like the hesitant to make errors, to make mistakes, and the people also around him does not take his or her mistakes so seriously. So if you want to learn a programming language, you have to be ready to make mistakes. You have to accept your mistakes, understand your mistakes, and correct your mistakes using the browser or using the web-based support or by the some experienced programmer. So you have to read good programming book, good programs, you have to write programs, and you have to make errors, and you have to understand your errors. So I will briefly go to the runtime error. Common examples of runtime error are variable names or the names not defined, unsupported operand types for plus, like if you want to add one integer and a string, then it will create the runtime error, then zero division error, index error if you want to, if you are dividing two numbers where denominator is 0, you will get zero division error. If you are trying to access something in a list or in array, that like we out of the last index, then you will get index error. Suppose you are running the print t, but you have not defined t. So I have to select kernel. That's why it was not running. So data science kernel. No, I will print t. So name t is not defined. So yesterday, few people were like the facing similar type of error. Name this is not defined in the same functions. They were like they have not defined. So yesterday they were telling I have saved some variable name like var equal to see my dir, and they were instead of like this, they were like writing df dot to like the 2 underscore csv, and instead of var they were writing my underscore dr, and that too without code. So my dr is not defined, they were getting error like that. Okay, So if you have not defined a variable and using it, you have not, so it will give the name t is not defined. Now, if you are adding a string with a number, then also it will not make any sense. So it will give unsupported operand types for plus unsupported operand. So what is operand here? One is another, one is one operand, ABC is another operand. Okay, so and this is operator plus operator. So unsupported operand types for plus int and str. So again, if you divide 2 by 0, it will give 0 division error. And notice this 0 division error, camel case. Most of the error names you will get like this 0 division error. So colon description division by 0. So now L equal to 1, 2, 3, but you are trying to, there are only 3 elements in the list, but you are trying to access 1000 element. List index out of range and name of error, again camel case, index error. Okay. So what to do with errors? Sometimes you expect that in real time something might happen and you don't want your whole setup, whole program to run or suddenly break the executions because of a certain errors. So how to handle those situations? Because in practical life, whatever you do, the errors might occur. Like sometimes might occur, like in the, suppose you are filling a form also like the give you the error message, like the 10-digit number is not there present in the mobile, email pattern is not correct, @gmail.com, @gmail is missing. So this kind of, even the error checking in the form is also supported. Okay, so how, if we don't support the error handling, what will happen? Our big program will behave abruptly, will break the execution abruptly without saving the all the results, temporary results. So we want to catch the exceptions, we want to handle those exceptions. So the, for the Python we have the try and except block. So basic syntax is try something, except something. This is the basic clause, try except. So try something, if something happen, write something in exception block. So basic syntax is that try colon, and again any block start after the colon, and every sentence or every statement in that block start with an indentation. So here you see this IDE has automatically converted a tab with 4 space. So this is a 4 space. I have written tab here, but it has converted me it as a 4 space. So a indentation in Python either start with the tab, 4 space or 2 space. So try print this gets executed first, then except block prints this gets executed only if there is an error. So this is a general standard template of try except block. So when we run this, this gets executed first because we don't get error in this running this block. Okay, so we will see try except block with the error. So here try print let's try something, and intentionally we were creating 0 division error, x equal to 1 by 0, and then in the except block we want to write something bad happened. Here let's try something bad happened. So I think in everything is clear till now. So I will give you 10 seconds to sync, or if you have any doubt you can type in the chat. Okay, I will proceed. So I will define a function that catches a 0 division error, like def save divide a and b. It takes the 2 parameter. It will try to divide a by b and except return. If there is any exception, it will return very small number, 1 e to the power. So it means 1 into e to the power 100, e to the power minus 100. So it is a very small number. So it is run. Then we try save divide 1 2. It gives 0.5. Then if we try save divide 2 0, it gives 1 e to the power 100, very small number. Okay. So what is a problem here with this code? like it catches zero division error, but there might be other case of error, like we are trying to add integer with string. So in that case also it will give very small number. So this is a logical error. Okay, logically it should not give me this small number. So how can we correct this? We can correct this by telling that we are expecting a zero division error, and in that case only you should return a very small number. Yes, e to the power minus 100. So this is the syntax for writing e to the power minus 100. Okay. So it means e to the power minus 100 only, I think.
Plus
E to the power plus 100. So it is a small number or it is a big number? Like just I will check the e to the power 100, 1 e 100 greater than 100. So it is true. So it is a very big number. So I should return 1 e to the power minus 100. So like yes. Thank you, Devender, for correcting. It is a big number. It is a very big number, and I checked that by checking this, that 1 e to the power 100 greater than 100, and it is returning me true. So it is greater than 100. So it is a very large number. So we should return here e to the power minus 100. Thanks for correcting the typing mistake. So this save divide 2 0, it is giving me very small number. Save divide 1 2, it is giving me the same small number. It should not give me the small number. So to correct that, we should tell that we are expecting this particular class of error, zero division error. Notice the camel case here, zero division error, and we should return here 1 e minus 100, very small number. And then this was just to check. Then if we do the save divide 1 0, it will return very small number. If we do save divide 1 and string 2, it will give us error like unsupported operand type for int and str. Okay, so done here. So how to, sometimes you also want to hand like the range and exception, some unexpected thing happen and you want to report this or make a log of this exception. So Python provide a keyword called raise. You can raise your own exception. So raise runtime error, my error message. So this is the syntax when programmers or application want to raise an informative exception. So like it will just print like this runtime error, my error message. Okay, so you are instantiating the runtime error and you are customizing the message here. So suppose let us take a example of Fibonacci series. It takes a input n and prints the first n number of Fibonacci series. So def Fibonacci n L to store all the Fibonacci number. It starts with the first two Fibonacci number 0 and n, and when the till the, this is a demonstration of while loop. Those who have missed yesterday, they can see here, while length of list is less than n, a b equal to b and a plus b. So next a number of the series is b plus a, and the a b will be rephrased, the like the first two number will be rephrased as b. So a will be replaced by b and b will be replaced by a plus b, and then l dot append a and return n. So this is the way Fibonacci number is defined. Now we want to run this for different numbers. So let's say we want to input the n equal to 5, then we get the first 5 Fibonacci number, we run it again 1 1 2 3 5. So it should till 0 1 2 3 5 or 1, no, 1 1 1 1. Okay, first time it will replace 1. Okay, 0 1, and then if we are telling n equal to 10, then it is printing first 10 Fibonacci number. Likewise, But what if we are giving the -10? It is giving me empty list, but it should tell that for -10 the Fibonacci series is not possible. So we can raise an exception. If n is less than 0, raise value error, n must be non-negative. Okay, so depth Fibonacci, it will first check if n is less than 0, it will raise the value, and other code are the same. So when I run this, we will get Fibonacci -10, n must be non-negative value error. So this message we will get. Okay, diving deeper into exception. So sometimes, so we might like the want to know details about the error. So suddenly some general exception we are just having, like here we are having the specific class of error, but sometimes like we are getting error, but we are not getting the what are the class of error, what is the details of the error. So we can get the type of the error and error.message, error.info, like that. So here we are getting the details of the error using like this: except zero division error at error, or even many times the programmer likes E because programmers are lazy, and then they will tell error classes type error and except message error. So like that. So try x 1 by 0, accept zero division error as error, print error classes type is telling the what is the class type and what is the error message. So error, so we often write it as a E. So error class is class zero division error message is division by 0. Okay, so E dot message also, if you like, even if you write here that error dir, what is the present in the error, what are the attributes present in the error, that will be covered more in when we class debug. So these are the error attributes: cause, class, context, dark, blah blah blah, rs with trace break, like that. Size of one thing will be message dot message, somewhere dot message, cause, class, context, delimiter, dir, doc equal to format, you get attribute. Don't get confused by so many things. Much of things like the is the part of internal class, and we will see that while dealing the class. So defining custom exceptions. Suppose we are defining my custom exceptions, and again this is a part of class, so it will make more sense after the class lecture, but still I will just briefly go through it. Class my special error, and it is the subclass of value error. So subclass we will tell afterwards in the next class, but for now, so it is like the children of the value error. So it will inherit all the attributes and the function of the value error. So my special error is the children of the value error. So all the default property of value error will be inherited by my special error. That's all you can understand for now. So my special error, value error pass and raise my special error, and here, but yeah, you can inherit the your parents property, but you also can create or your own property, or you can like the change the custom property of your parents. So they can inherit or they can override the parents message, parents property, parents function, parents attribute. So like this. So here is the message: my special error, how to stop unending run program. So here you can see there is a option to interrupt in both, like the Jupyter notebook and in the VS Code. You like if you are running a cell and it is going infinite time, you can click on interrupt and it will stop the infinite execution. Or best thing is that you can close Control C if you are running on the terminal and you are running some program Python something .py and it is going in infinite loop. You can do Control C and it will break the execution. So then try print do something, raise my special error, informative error message here, except print do something else. So do something and then it raise my special error and comes to the exception block, do something else. So finally it is like the least used thing, try except else finally. So if it doesn't go to the try block, like the try, doesn't get the cached any error in the try block, it will go to the else block or final block. It will anyway executed even if there is an error or there is not any error. So try something error, print this happens only if it succeeds, because there was no exception in this statement, and finally this happens no matter what. So this is the end of today's session. Thank you for being with us and happy learning, and we would love to answer your doubts throughout our week, and we take your feedback very seriously, so we even analyze your feedback. So please give your feedback if you have not given yet for day 1, day 2, day 3. So like I will show you, we even see each feedback, each comment, and if needed we call the student, we solve their doubts. So I will show you just that we even analyze the each feedback. So this is the analysis of the for day 1 of the workshop. So like see, we got like the in the content of the workshop we got mean as 4.08 in the, and this is the like the we got 42% have rated 5 out of 5, and 32% have rated 4 out of 5, and so on. In the presentation we got mean of like the 3.98, and like the 42% have rated 5 out of 5, 32% have rated 4 out of 5. In the learning new things, 44% have rated 5 out of 5, and this was the first day where only the installation happened and we got stuck due to the confusion over the many thing, but still we got a good response, and this was the sample size of 50. So like this, and we are also telling the seeing the like the which operating system they were using, and for Windows 7 those people who were facing issue, we have sent a separate mail. Yeah, welcome. But just final thing, for the next lecture it will be very important, and it will be our sincere request to kindly go through this IPNV file and before the next lecture, so that we can quickly cover the things. So course structure and syllabus, just I will briefly go through the what are the contents in the next lectures. So
Next lecture, what will
contents
from here?
yeah. So we will cover the plotting with matplotlib. We will cover the plotting with pandas and different types of plot. Very nice plot, and like the Rahul had really created the PPT and the code with very good effort. So just make sure that you attend the lecture and you just revise the briefly the today's lecture and yesterday lecture. So different type of plots like line plots, bar plot, and this kind of plot you can directly export the code for your research purpose, like this stacked bar plot, like this aggregating based on the some like the attributes, like this pie chart, customized pie chart, box plot, quartile, like this legending, and like this distribution, then violin plot, this, then scattered plot, and so much thing. And then this is the density plot,
Like
correlation plot,
is
and
there for continuous data. Then Kramers V association plot. Kramers wheel plot, and then in day 6 we will generate also some publication ready plots using plot 9, like this kind of line plot, then dotted bar plot side by side, then stacked bar plot, then with faceting, like when we have two categories or we want to separate the plots for different combinations, like lunch and dinner, and for day, what is the total bill amount versus tip. Similarly, for distribution plot for over different days, we can also plot, and that is a publication ready plot. You will just import with 400 or 600 DPI, and you can put in your publication. Then density plots, then box plot with BSOM plot, where the dots are represented with male and female, how the data is distributed over the axis. then linear regression with faceted plots. Then sometimes we also try to see which distributions are fitting. So we can use the QQ plot with different types of distributions. And that way we will create. And also, I think
after that we'll show the basic machine learning model.
Yes, after that we also show the basic machine learning models, and
if possible I will try to show basic deep learning model using PyTorch or TensorFlow.
Another thing is that also some part I will show the interactive types of plot, like for plot 9 day. It's in plot 9 or yes, in plot 9 I guess. Just wait.
Yeah, we will share the feedback link over the WhatsApp and also the over the email within 1 or 2 hours. And please join the WhatsApp group if you have not joined so.
And also some part of Plotly, that is the interactive graphics. Like if you hover over this, it will show that where it is, what is the value, what is the thing, and what is the density. And also like if you want to plot a box plot and want to see which one this ID, whether it's an outlier or not, and what this observation number is. So this kind of interactive plot we will also cover a small part, because it is not related to like publication, but it is just for exploratory analysis.
And in the last day, we will try to give you the brief overview of the machine learning model and implementing like the machine learning using the scikit-learn. And if possible, like my aim is to give you the brief overview of basic deep learning model also using either TensorFlow or the PyTorch. And at that time, we will use the Google Colab, because installation, it has the good support of the GPU and the pre-installed library. So let's hope that we'll able to cover those things in the next week, but we need your support by revising these lectures. So thank you. And this is the end of the session. You can keep posting your doubts in the Teams link. We will give you the feedback link soon. And if somebody have not joined the WhatsApp group, please join. So anything from your side, you can write in your chat. Otherwise, we will conclude the session. Thank you.